How's everybody doing? So you all couldn't get into Mark Rasinovich's session. That's why you're here. Is that what I understand correctly? Yeah, this will be the real session anyway, so you'll hopefully get your money's worth. Brief introduction. My name is Chris Jackson. I am often known as the AppCompat guy. This is not my AppCompat session. That happens to be next in this very room. This one is all about Windows 8 security. Windows 8 security is a huge, massive, broad, and really hard to dissect topic. And in fact, at TechEd, there are at least 3 sessions on the concept of Windows 8 security that I know about that are somewhat similar in nature. One of them is Raiders of the Elevated Token, delivered by a buddy of mine. And it kind of goes into some of the same concepts at a different altitude. You know, my goal is to show them at a really low altitude. There will not be any PowerPoints shown whatsoever over the course of my entire presentation. Is that okay? I figure you might have seen enough already. And there's another one going on right after this session across the hall about what's new in 8.1. I'll give you a hint. It's child app containers. I'm not sure what else they're going to talk about. But when we talk about the aspect of security we're discussing here today, this is all about the access check, what you're able to get into. So when we think about some of the memory protection technologies, ASLR, DEP, that's not in here, right? It could be covered. It's good stuff, but that's not part of it. When we think about other higher order level of securities, firewalls, that's not in here. Safe boot, that's not in here. This is really focused on the aspects of security that are likely to impact your applications. I am, after all, the AppCompat guy, so I care about your stuff working. The other things might impact it, yes, and those are all related, but this is that chunk of it. If that's not what you were looking for, I'm not going to be offended if you walk out. It is going to be awesome, and you're going to miss it, but I'm not going to be offended. Right? But I want to set real clear the expectation. So are we good on that level set? That's what you came to hear about? Now, some of you may or may not know this. Do any of you ever present at conferences? Right? A couple of you do, right? Those who do know this. At every conference in the world run by anybody, if you don't use PowerPoint, you have to pay a tax. So what I'm going to do is I'm going to try and avoid that tax, and I'm going to try and use the closest to PowerPoint that I can without actually using PowerPoint. So I've gone ahead and started Notepad here in the debugger, and I'm going to set a breakpoint on user32, bang, set window text W, and when I hit that breakpoint, I'm going to edit memory, that which is pointed to by the EAX register, and I'm going to change the title of this to Untitled PowerPoint, and another escape quote, and disable all my breakpoints and go conditionally, and there we go. Now we have our PowerPoint. That's how you guys start it, right? Okay, and here's what we're going to talk about. We're going to talk about tokens and elevated tokens. This stuff has been around for a while. It is still the most frequently misunderstood concept of Windows security. So I'm just going to go over, review everything. Some of it is foundational. It's required. You probably know at least some of it. For the stuff that you know, my hope is that what you'll take away are new tricks and techniques to demonstrate it. For stuff that you don't know, what I hope you'll take away is knowing it. So just to be clear, not everything is going to be brand new for Windows 8, but it's all required for assembling a complete understanding. We're going to talk about integrity levels. We're going to talk about UIPI, or user interface privilege isolation, and how that works with the system. And then we're going to finally get into capabilities and app container SIDs. And app containers in general, right? And I mentioned that 8.1 is going to add child app containers. There are new scenarios for that. We can kind of branch into a little bit of that. But this is really laying the groundwork for the directionality of Windows security. And, oh, sorry, I'm being told that this actually does not count as PowerPoint. So, since I don't want to actually pay the tax, I've gotten a sponsor to run a shirt commercial to pay our PowerPoint tax. So let's hear a quick word from our sponsor. And, oh, you know what I need? I need audio. That would be useful. So give me 1 second here. Apologies. And can we make sure that we have audio coming out of my laptop here? Are we good? I'm plugged up. There we go.
Years and years ago, in 2005, computers used to look like this. Back when I was 1 year old. Look at this thing. It weighs way more than me. With Windows 8, my surface looks this small. And it is so much more powerful. And it also features mandatory integrity control. That's one of UAC for all your non-hackers out there. It keeps me safe when people try to hack me. I had my credit card number stolen 5 times. I don't even have a credit card. Now I'm protected by application isolation. It keeps me safe when I run my Windows 8 apps. Those are lots of bad hackers. Someone trying to hack me. I'm a hacker. I'm a hacker player. Own it. That's what I'm talking about. Windows 8. It is made of pure awesome sauce. Yankee, awesome sauce. I want you to pack my good player.
And in violation of probably several child labor laws. On we go with the show. So, foundationally speaking, all of the security that we'll be talking about today revolves around the access token. And the thing that I see misunderstood more than anything else is the difference between an administrator while their token is filtered and an administrator when their token is not filtered. So we can see that using the whoami command. And I'm going to dump everything about my token, and I'm going to format it as a list. And then I'm going to use Windows X to get me to an elevated command prompt. So if you didn't know that trick, that's a nice one to go to. And I'm going to do the exact same thing. whoami/all/fo list, and I'm going to dump the contents of my token. And since I am connected via direct access, I do actually have a pipe to get back and resolve the names against all of my SIDs. So it takes just a minute to go and run this. But while we're waiting, we can see that between these two different identities, a couple of things you're probably going to notice. The first one is both of them are me. They have the exact same SID, and they represent the same identity. This is fundamentally different than any other operating system that takes the concept of having a less privileged and more privileged user. They separate them out as two different identities. On Unix, I have my user account and I have root. On Windows XP, I would have my user account and an admin account if I were running as a standard user. A lot of people used a syntax of username and username -a as one common example. This is two different implementations of the exact same me. And boy, are they taking a long time to resolve. That is awesome. I love it when that happens straight away. Well, rather than waiting, since I am presenting without a net, I can always go and find those tokens represented elsewhere. So I'll go ahead and grab those, and I'm going to use Process Explorer. And within Process Explorer, I'm going to show details from all processes. And assuming it hasn't dumped yet, oh, of course, it happened just in time, I could see the exact same details. Process Explorer would let me see the exact same security information. I like seeing it in the blue and red juxtaposed against each other, so we'll go through these. Scroll back to the top, and we can start to explore some of the differences. One of the things you may have also noticed is that in addition to having the same SID, the same identity, I have a blue one and I have a red one, which is really convenient for demo purposes. And one of the most commonly asked questions I get is, how did you do that? cmd.exe stores its color configuration per shortcut. I always launch the blue one via Windows R CMD, which I have configured to be blue. I always launch the red one via Windows X, command prompt as admin. Different shortcuts, different outcomes. That's why they're different colors. There's no magic that's doing detection and setting the background color. It's just two different shortcuts. So as I start to explore the differences, the first one that I notice is in the administrators group, where one of them just calls it a regular mandatory group, but my blue one, my non-elevated token, says it's used for deny only. This is a flag that's been around for a while that indicates I cannot use this entry in my token to be granted access to something. I can only use it to be denied access to something. So if I want to get into something in program files, that's a grant action. That's an allow. I can't use this entry to allow me to do something. I can only use it to deny me access to something. That's why I can't write there. So a good question you should ask is, well, what's so special about program files? What is it that admins should do and standard users should not do? To me, it comes down to a very basic rule. A standard user can hork all of their own things. Hork is a technical term. It means to mess up. An admin should be able to hork everybody else's stuff also. That's the difference. So, program files. Everyone uses the same one, which means you can't mess around with it, because otherwise you're impacting other users. The Windows directory is shared. You can't mess around with it, because if you did, you're impacting other people. The root of C is shared, so you can't mess around with it or you impact other people. Your documents belongs to you. You can do whatever you want to. It's yours. Same thing in the registry. Local machine, everyone shares it. You can't mess around with it. HKey current user, it belongs to you. You can, by default. That rule just applies over and over again across all of the concepts. So it's a really easy way to conceptualize. It's not that the name is magic. It's not that there's anything inherently special about that. It's just that that's what it is designed to do, is to protect the overall machine. So that's one difference. And as I start scrolling through the rest of my token, it continues to look the same. I've got all of my group memberships intact. And they're identical. And boy, do I belong to entirely too many groups. So it makes the scrolling go longer than it ought to. But the next difference that I see is this mandatory label entry. We're going to talk about that one later. That's the integrity levels. We're getting there soon enough. Finally, I get to this list of privileges. And that's the next area of significant differences between an elevated token and a non-elevated token that also is commonly misunderstood. What a privilege means is I'm going to give you a special permission to violate that rule we just stated, which is to potentially hork other users. You'll find yourself starting to use that term, right? I didn't make that up, but ever since I heard it, right, I can't stop using it. But if you think about what these things are allowing you to do, shut down the computer. Shutting it down, does that impact other users? Yes, the computer's turned off. But if standard users can't turn off their computer, it's not a very usable machine. SE change notify. Does anyone know what that privilege does? Not many people do, because it's got a horrible name and it's two things at once. Right? Change notify allows me to get notifications that something has happened so that I can update Explorer. That's pretty useful. It also allows me to bypass traverse checking, which means if I have a long path, I don't have to access check at every single intermediary point along the way, so it saves me some time. Why are they grouped together? No one has any idea. I'm sure someone of the original architects probably knows why they slapped them together. Undocking, right? It's not very useful if I can't pull my machine off the dock as a standard user. But clearly, if the machine's walking away, other people are going to be impacted. One of the things we added for Windows Vista was the ability to modify your time zone. On Windows XP, run as a standard user. How many of you are on Windows XP still? Anyone? So like 4 or 5 of you? A few of you? Do any of you run standard users on XP? Yeah, not many people did. And one of the reasons why is it was not very functional. You couldn't change your time zone. And if you ever travel, you realize just how annoying that is. Because we tied time zones and time. Changing the system time is an admin behavior and remains that way. Because if I can change the system time, one thing I can do is I can do a denial of service. Kerberos, the authentication protocol, requires you to be within a particular tolerance of the server. Change the time, no one else can log in. A little bit irritating. The other thing, probably more importantly, is repudiability. I can go in, change my system time, do something bad, change it back, and then when that time happens to come, be in a highly visible place far away from computers so that I have an alibi that says I can't possibly have done that naughty thing. In the audit logs, right? You could potentially do that. It's an admin operation. Changing the time zone, yes, it does impact other users. Yes, it can be really annoying if you want to really mess around with people. Pick one of the half-hour or quarter-hour time zones to switch it to, because that really messes people up. But doesn't cause the same kind of security issues versus what you can do as an admin, which is SE backup. I can read anything I want to on the file system without an access check. SE restore, I can write anything I want to anywhere in the file system without an access check. SE debug, I can get into any other process on the operating system without an access check. Really, really dangerous stuff. The list in my filtered token looks an awful lot like the list that I would see were I a standard user, and that's by design. When I talk to folks who are planning standard user deployments, how many of you run today or are on your way towards running a primarily standard user environment in your organization? And how many of you are trying to get all the way there? All the way is hard, right? Because when you start talking about developers, there's some stuff they can't do if they're not an admin. They're the hardest group to pull it away from, both for psychological reasons, like they don't feel like they're quote-unquote standard users because it's an emotionally charged word, but for practical reasons as well. If they're developing on COM, they're doing installs or packaging, it becomes really hard to actually operate that way. UAC enabled for an admin fixes one of the biggest problems we see from those same developers, which is them accidentally writing admin dependencies in their software. This means they look like a standard user most of the time. It's not a perfect emulation, but it's pretty good. And it really has changed the software ecosystem dramatically without having to actually strip everything away. Of course, the next challenge is developers are the ones most likely to try and turn it off. We just continue to tell them to try to turn that back on, and we'll talk about why having that turned on ends up being really the best idea. So those are our tokens, right? Really foundational, but it's important that we all have those basics in mind as we start to build on them. As we start thinking about them, we want to start thinking through some of the design implications of having run and built our tokens that way. So when we think about what's happening, we've got winLogon, and as an architectural basis, how this happens is winLogon goes through and creates my elevated token. It then goes and creates my filtered token, and it then launches Explorer using my filtered token. And the way that you get your token is you inherit your token from your parent process. And then each thread gets it from its process. The threads can each be modified. The processes can be modified. But you get whatever your parent gave you. When I'm going through and creating these, that means since most things are launched from Explorer, they launch with the filtered token until I explicitly elevate, and we'll talk about that in a second. One thing I wanted to mention was how this architecture potentially could impact you from an app perspective. How it could impact you is that we create a logon session here and a logon session here. Different from a terminal services session, right? We love to overload terms at Microsoft, just like .NET in around 2003 when everything was something .NET. Sessions get overloaded. Logon sessions are where we store mapped network drives. It's where we have always stored mapped network drives. We didn't change that. If we change that, we're going to break stuff. That's why we didn't change it. But what are the implications of that legacy? When I get my non-elevated token and I run a logon script, and it maps a bunch of network drives, and they're now in that logon session, after I elevate, will I see those mapped network drives? No. It's not new. That happened on Windows XP. You can try it. Get an XP box. do a run as.exe, run as yourself, and you won't see your map drives in the second copy of you in the separate logon session either. The difference is, on Windows 7, Windows 8, people actually elevate. On Windows XP, no one actually does that, logging on as themselves. So it just becomes far more prevalent. So we have that architectural basis, and then we also have how do we go through and elevate it all. Elevation always happens through a shell execute. It doesn't happen through create process. Right? So another thing to think of architecturally, what's going on in the innards of Windows. The question is, why might that be? And that's because of the layering work, whoa, don't do that, that we've been doing in Windows. I keep getting too close to the top. We are refactoring Windows and continue to with every single release. And one of the things we began doing in Windows Vista and really did a ton of work on in Windows 7, if you heard of MinWin, that was all around this initiative, which was to have Windows organized into a series of layers to start to remove some of the spaghetti intertwinings and incestuous relationships between Windows binaries themselves. So you'll start to notice things like implementations of some functions sitting in this new DLL called kernel-base.dll, even though they were sourced from something else. That's all part of this layering. The idea is a layer 0 component can only depend on other layer 0 components. Layer 1 can depend on 1 or 0. Layer 2 can depend on 2 or 1 or 0. And this architectural purity that we're trying to move towards has the potential to impact your apps. Because if I think about, well, creating a process, create process is pretty fundamental to Windows. You really can't schedule a thread to work until you have a process in which it can operate. So it sits in layer 0. What about elevation? Elevation requires me to potentially show you a dialog box, which requires a window manager that has group policy to read. Can I have a version of Windows without a dialog box? We ship one. It's called Server Core. So that's not in layer 0. That's higher up. So we can't take that dependency. Thus, we can't use create process to do elevation. You'll get status elevation required if you try to do that. And you'll have to use create process to actually get that to work. So using create process, that calls into the application information service, which calls into consent.exe. To determine whether you're allowed to do it, consent.exe is what will show you the dialog box, the infamous UAC prompt. And if the answer is yes, whether from policy or whether from the user, we will go through and create the new process, and we will then reparent it so it looks like it came from the launching process that called create process. The architectural impact of this, just because nothing comes without a side effect, what happens if I'm passing information to my child executable via an environment variable? I set it, then I make it, and hope it gets there. Where do you get your environment block in Windows? From your parent process. Who's the parent process of this one? The App Information Service is what launched that process. The App Information Service already has its environment block, which probably happened before you set those variables so they don't get there. I've only seen a handful of apps impacted by that, but this is some of the complexity that we're dealing with when we think about legacy applications and innovations. UAC was really designed to make standard users possible at all. That's why the entire feature set was created. UAC is not prompts, it's a bunch of other stuff. This is not a UAC, gung-ho session, although I'm happy to have those conversations about why I think it's really critical, but that's what it really comes down to. I'm checking to see what I'm allowed to do and not allowed to do. UAC is far more configurable than a lot of people think. One of the things I love about the control panel is that you have search, and I especially love the fact that if you search for the word prompt, the one and only return that comes up is user account control settings. Like, oh, if you're looking for prompt, that's probably what you want. So we try to simplify this, right? And every time we try to simplify this, we leave a lot of complexity on the table. the slider that everyone knows and loves, maybe. All the way down on Windows 7. What did that do? On Windows 8, what does it do? It does not turn it off. Yeah, it's different. The complexity is all revealed inside of the group policy. So I have to go into the group policy editor to actually see all of the different options that I have for configuring user account control. And so how many of you are from the IT admin or IT pro side of the house, as we call? So what 2/3 of you? Developers? So about the remaining third. OK, so the developers are like, what is this thing on the screen? And the IT pros are like, wow, it's about time he got some policies on here. The security policies always take an incredibly, hideously long time to load. I don't know how all the IT pros put up with this. But it is in here that we can go and see the full granularity of what is available. Wow, this is like really taking an irritatingly long time. Let's see if I can launch it directly through SecBall. Or maybe not. Even more awesome. I know. Yeah, well, you know what happens? You get impatient sometime. But when I'll just start talking about it anyway, right? Like I said, we are presenting without a net today. What are the group policies that you have to configure? When it comes to what you can do for admin users versus standard users, really there's one big difference. For admins, the policy all the way at the bottom today on Windows 8 says auto approve. So every single time an application requests to be run as admin, it automatically says yes, the user is never asked, a prompt is never, ever shown. You can knock that up one, which is a change we actually made for Windows 7 that says auto approve for Windows binaries, and to be real specific, it's a Windows binary in which the manifest specifies that it doesn't accept command line arguments. That's why regedit, which doesn't auto-elevate, but MMC will approve at the MSC or the snap-in level, and others will just auto-approve. Like so it's not quite as simple as what it appears to be. So I have that auto-approval, and I finally have ask the user or be really irritating and make the user type their password again, right? The super irritating one. But I have those different options for how do I approve. For my standard users, I really got two choices. Either ask someone to type or automatically say no. I also have the option to turn the whole kit and caboodle off. So one of the things that I, as a developer by trade, have learned about group policy is that the way that group policies are named, I've inferred, is something like this. They get people to walk in, they walk up to a keyboard, they take their face, and they smash it against the keyboard a whole bunch of times. And any English words that come out are what we use to name our group policies. So this says run all admins in admin approval mode. Seems like it's related to admins, right? This is UAC on or off. You still have a group policy to turn the whole thing off. On Windows 8, it turns out to be a really bad idea. It's a pretty bad idea on Windows 7. Windows 8, because it is foundational for all Windows Store apps. Even your side-loaded Windows Store apps, because we don't have a cool name for them anymore, so we call them Windows Store apps, and because our marketing team doesn't know how to come up with cool names, apparently. None of them will work. This technology is foundational. On Windows 7, you lose things like protected mode, which is used by a growing suite of applications. On Windows 8, it's used by all of them. None of them will launch without it. It is getting to be a worse and worse idea. And one of the things you should be aware of, we at Microsoft, for Windows 8 and for Windows 8.1, did exactly 0 testing with UAC disabled. We don't know what happens. So you might want to take that into consideration when you flip the off switch. We still have an off switch, it's still there. When I think about configuring it, really the experience I think about is what am I going to do for my standard users, because the defaults really are optimized for your house. How it works in my house. If one of my kids tries to launch something and a UAC prompt comes up, they can raise their hand and say, can you type this thing in? And we'll say yes or no. Why is someone calling me right in the middle of my session? And why is my phone on? But at a place of business, I'm guessing you don't just have admins roaming the halls waiting for someone to raise their hand. Instead, they're probably calling a help desk. It all comes to optimizing for the help desk scenario in terms of how you configure this. Are you going to have the help desk type in credentials? In which case, make sure they can. Make sure that you know the software you're using, whether the software is remoting the secure desktop or not, so that they can actually provide credentials if you want them to elevate. If you don't want them to be able to elevate, then make sure they have a procedure to get admin rights on the machine, because the other option is to always say no. Right-click Run as admin will lead to a dialog box that says this program is blocked by group policy, even for your help desk people. It's all about lining up the experience end to end. But that is really, kind of how the policies come together, and think about that. Now, I mentioned along the way when things elevate, and this is an important thing that also a lot of people don't completely understand. How many of you think that we actually go in and look at the program and determine whether it's going to need admin rights through some logic, or we wait until we see you try to do something protected and then show you a prompt? Does anyone think that? Because we see people who kind of think like, oh, it's prompting because it needs to do something. Elevation always happens when you're creating a new process. It does not happen in line. And it happens based on a set of criteria. And it's not based on whether you actually need it. It's based on whether the IT admin or the developer asked for it. So if I go to, I'll go find an app that I know requests elevation, Windows Kits, 8.0, Assessment and Deployment Kit, the App Compat Toolkit, Compatibility Administrator, and then I will use another sysinternals tool, which is sigcheck/m compatadmin.exe, and I'll dump the manifest. The manifest file is a bit of XML that the developer can include that specifies, do I want to run, in this case, as highest available. Highest available is the weird one. I have three choices. Run as invoker. Whoever I am is fine. Just stay there. Don't elevate if I have not elevated before. Run as admin is, if you're not an admin, ask to become one every time. That will guarantee you see a prompt. This is the halfway one, which is run highest available. That means if you have a split token, you have two of them, and you are not using the most powerful one, then elevate to use it. So admins will see a prompt, standard users will not. Which is really confusing if you use both types of accounts. I don't really like using this one, but you can put that in. This manifest is a bit of XML. Developers include it. There's a tool that's part of the SDK that no normal human actually uses called mt.exe, which you can use to configure that. What normally happens is that Visual Studio put it in for you. If you happen to be a Visual C++ developer, you get all three choices. If you happen to not be a Visual C++ developer and you're writing in .NET, you get one choice, either the default, which is as invoker, don't elevate, or to not have a registry entry at all. There are other consequences of having a manifest, which are important to be aware of. When you have a manifest, you not only get to specify how you elevate, whether you do or don't, but the sheer presence of a manifest requesting elevation will turn off other application fixing behaviors of UAC. So things like file and registry virtualization go away as soon as you have a manifest. So if you're fixing an application which has an extraneous prompt by throwing a manifest in, you may break it in other ways. So I could elevate because a manifest asked for it. That comes from the developer. The other thing that could happen, and I can show this in a tool called Compatibility Administrator. This tool ships as part of the Application Compatibility Toolkit. The Application Compatibility Toolkit is hiding inside of the Windows Assessment and Deployment Kit. Don't ask me why it's hiding now or why it's so much harder to find, but it is still there. So the developer could ask for it. The IT administrator could also ask for it by putting in a flag in a custom shim database. That is another option. The final thing that could cause you to see an elevation prompt is that we are trying to get you working because we think you're a setup. So thinking all the way back, rewind the clock to circa 2006. Actually, this was probably around 2005. During the run-up to Windows, what became Windows Vista, at the time it was called Longhorn, every single day in the Windows division, we run automated tests of applications. At that time, it was a little over 1,100. Today, it's over 5,000 and probably well beyond that. We finish a daily build of Windows, we run all the tests, and we measure what worked on the last one that doesn't work on this one. And we are in the beta 1 builds, we're running in the high 90%. The very first beta 2 build is where we enabled UAC by default, at which point we dropped to about 20%. And we said, ooh, that's not so good. So 4 out of 5 pieces of software no longer working. No one's probably going to buy that. So what do? And the biggest problem we ran into is that every setup.exe in the world was suddenly running with standard user-like permissions. So step 1, let's go find all of those and start running them as admins so that things install in the first place. How do we find them all? Well, we can't tag every single one in the world, so we run some heuristics. Turns out those heuristics are visible inside of compat-admin. You can see how very complicated they are. Turns out we're looking for the word setup in a bunch of different places. And if you happen to speak Japanese, we also have both full width and half width katakana looking for setu uppu. Look it up. And we also look for it in the name. All right, and I can real easily make something look like a setup by renaming it and including the word setup. Straightforward. Setup, update is another one. We look for the word update. Go back home. Install. We put under installer detection. You can see INSTAL. By the way, this is one of the more interesting conversations I had was with the folks from Flexera Software who make Install Shield. Turns out that division of their company, absolutely everything was prompting for elevation. Because they all had this string in it, because it's the name of their freaking product. And finally, patch. Yep, typed that wrong. Same thing. We look for the word patch in there. That's it, right? It's really simple. It's really straightforward. And guess what? Sometimes it's wrong. So how do you fix that? Well, you could put a manifest, but that could potentially break you in other ways. So there turns out to be another feature, which is the specific non-installer flag that you can apply via a custom shim database. We talk about shims in my app compat session, which is coming up next in this room. This is about the security side of things. So I have non-elevated tokens, elevated tokens. I get to elevated because someone asked for it, or because we think you're a setup, right? So moving forward on the baseline, that's foundational. Where we extended it, and what people are still starting to catch up on and we're starting to understand now, is now in addition to doing authorization based on identity, these are two different versions, but they are in essence two different identities. Within the same identity, we can now start to make authorization decisions based on the extent to which you trust a given process. This is also very different and very new. This has been around in academia for a while, but there's not a lot of commercial implementations of this either, which is why some folks are still sort of working out how to deal with it. Integrity really is a 32-bit number, right, that says, compared to everything else, do I trust you more or less? A higher number, more trust. Lower number, less trust. It's a 32-bit number, so how many different possible integrity values are there? About 4 billion. How many do we actually see? 4 primary ones and a couple of tertiary ones. Because we just don't need 4 billion right now, right? But we could grow into that at some point. The idea behind that is you've got low, medium, high, and system. System, that's typically a service that's running. High, elevated process. Medium, standard user process or protected admin process. And low, a specifically and uniquely untrusted process. All those different levels. So now we can start to make decisions to say, oh, you're less trusted, now I won't do anything for you. And I can actually see that. I'm going to use another sysinternals tool called psexec, which lets me launch a process configured in a different way. I'm going to launch a process, and the -L switch will launch it in low integrity. I'm going to say, this is an untrusted process. And I'm going to launch Notepad. And now, from Process Explorer, I can use the window finder to go find this process and see that, aha, here is notepad.exe at low integrity. Low integrity is represented in the access token by a SID, S1164096. And this 4096 represents the actual level at which it runs. That's the lowest one. And I could see the exact same level represented as a SID. It's yet another entry that has special behavior inside of the access check function to determine whether I can get there. So my process has an integrity level. Every securable resource has an integrity label that specifies who can get there. If you don't explicitly label something, it will default to medium with no write-up. Right? There are 3 different things you can block: read, write, and execute. No read-up means anything with a lower integrity level can't read me. No write-up, you won't be able to write there. No execute-up, you won't be able to launch a process from there. Default is no write-up. That's why we call it integrity. It's about protecting the integrity of your system, not the privacy, because you still have read-up by default. So let's take this and make a this is created from low and try to save it. File, save as, and we'll go ahead and drop this in my documents, and we'll say low, and we'll immediately get an error message, and we'll learn the lesson that I learned long, long ago, which is that error dialogues love to lie to you. Hey, we don't have permission to save it in my documents. How about saving it in my documents instead? Well, that's really helpful. Let me go ahead and say yes, and oh, it'll have the same problem, because I still don't have permission to go there. I'm not going to be able to write there. Now, what I could do is I could use a medium integrity notepad. If I go to this one, I can see this one's running at medium. I could say, this is written at medium, and save this into my documents. And it's saved just fine. And I can even go and open this from my low integrity process. I haven't blocked read up. I've blocked write up. So now I have this trust behavior. And you can also flip that policy. And I always like to see this as well. I'll go ahead and use a command line tool that's written by Mark Benassi. I'm going to go to C, users, my name, and documents. CD, users. Let's see if I type it correctly. And I'm going to use the command line utility that he wrote. He posted it up on his website called CHML. And I'm going to call it medium.txt. And I'm going to set the integrity level at that document as low. And now that it is a low integrity document, I'll be able to save. Whereas before I could not. The other thing I could potentially do is I could say, oh, you know what, let's go ahead and change the policy on that to medium with no read up, no write up, and no execute up. Let's make sure no one else can do anything on this thing. And now we'll go ahead and try to open it. We'll open the same one, and it will come out as blocked because it is now no read up either. So this, I think, is something that's worth developers thinking about. I now have the ability to put in access control that says, I'm going to block who can read this thing or who can write from it. And there are some scenarios where there may be some very security-specific things which I could do with that. That's potentially interesting. I haven't seen a lot of code written to take advantage of that. I see very little knowledge of the policies at all. People get the levels, low, medium, high. I'll do that. We're not the only ones using that. If you kind of look at what you already have today running at various integrity levels, what I'll do is I'll just sort. Go to the bottom, all right? I've got Notepad running at low because I launched it there. But I can also get Internet Explorer, protected mode, runs it at low in that sandbox to protect the integrity of your system. Other things that run with lower integrity, Google Chrome. Not only runs at low, it runs in its own very special level, 0. We'll just throw it at the bottom. That way nothing else can get there, right? It's a 32-bit number. That's a legit SID. I don't know that that adds any particular extra security beyond low, but it certainly makes sure that you can't get into your Internet Explorer stuff. Adobe Reader. Whoop, that's if I spell it right. I'm still not spelling it very well. Adobe Reader, starting with Adobe Reader 10, also runs at low integrity. And you're starting to see more and more apps. Office 2010 Protected View is low integrity. This is foundational. I can start to isolate and put these things into a bit of a sandbox. Now, the sandbox is imperfect, and we extend it for Windows 8 apps because you can start to see where the model breaks down. Today, while the apps that run at low are at limited in number and are the high-risk apps, living together in the same cesspool, not such a bad idea. When I start to think about running more and more stuff there, suddenly if the cesspool becomes where everything lives, then just all being in the same cesspool has just moved you to a new neighborhood, but you still have all the same neighbors, and you're not protected from them. So Windows 8 goes further. We'll get into the details there. This is just the foundation of where Windows 8 goes. And this goes beyond just files and registry keys. It also has to handle the user interface objects as well through a feature called User Interface Privilege Isolation. How many of you, from the developer side, the third of you or so, have ever written Petzold style C that actually writes the message loop? Anyone? I see kind of a, like, back when I had hair, I did that. That was me saying that, by the way. I still have some hair. We'll see how long it holds out. Most people don't. So most people don't think about Windows operating this way. So I'll just show how it operates. This is a tool called Spy++. Spy++ is distributed as part of the Windows, as part of Visual Studio. I don't know if we ship it with the SDK anymore, but it certainly is in Visual Studio. And I'll also launch the calculator. And what I'll do is I'll use this window finder to say, find me the window for the calculator and show me all of the messages. How Windows works at a base level, it's a message-driven architecture. Every time something happens, we send a message to that window, and boy, do we send a lot of messages. Every time something is clicked, every time keyboards are struck, every time a mouse moves anywhere. Every Windows program in the world you can essentially break up into two parts. Part number one, WinMain, which also happens to be my license plate, is the entry point that sets everything up. Oh, I'm not kidding. It's a little Mini Cooper. It's awesome. No one, by the way, gets that. So, right, eventually I'm going to drive by someone who's like, WinMain. Oh, that guy's a Windows developer. I'm not holding my breath, though. So WinMain sets everything up, and then it all goes into this function called WinProc, which is just a loop. Pick up your messages, do something. Hey, did a mouse move? Do you care? If so, respond to it. That's how all of Windows works. Keyboard goes down, window message, handle it. Keyboard goes back up, window message, handle it. Mouse moves, handle it. If you want to get the text, send a message to a window saying, I would like to know what text is inside of you, and it sends a message back to you saying, oh, here's what is inside of me. And it is that very structure that allows you to do things like UI automation. And with UI automation, here's the potential risk. So I've got this application that's doing something that I'd like to be protected. It's doing it at medium integrity, right? But the action is something that's potentially risky because I cannot tell the difference between a window message sourced from an actual physical mouse and keyboard and a window message that is generated by software. I can just go through and do whatever I want to do and automate that. And if you think about, hey, I have an untrusted application sitting on there in the middle of an environment with a bunch of windows who it may know the name of, it can just use UI automation to get its own elevation of privilege, even if you have its sandbox. So on top of this notion of protecting file system and registry keys, we also have the ability, if you have the window running from a higher integrity process, right? This one is, oh, you scrolled away. Running at high, right? And this is a window that's running at medium. This medium integrity process, the window messages will be dropped. They never get delivered to protect it. Right? So we can understand kind of how we have this protection baked on top of it. Rewind. Here's what we've covered. Right? We have UAC, we have two different tokens, right? All these different permissions, privileges, blah, blah, blah. Elevation, how elevation happens. We have trust-based authentication with mandatory integrity control or Windows integrity levels, whatever marketing calls it. UIPI, all providing this baseline foundation of security. It is on this foundation that we are now ready to talk about what's new and different in Windows 8 for Windows Store apps. This is as far as you go for desktop apps. Windows 8 apps adds on to it, because here's the problem we're trying to solve. How many of you love to just go on the internet, find an exe, download it, and run it, and just feel completely comfortable doing that? Right? Because what? Somewhere on the order, he's like, yeah, on your machine, not on mine. That's a problem. Somewhere on the order of 30 to 40% of all binaries found on the internet are malware or have embedded malware. So of course no one trusts it. Yeah? That's a big problem. So how do you have an environment in which you download stuff all the time and you can start to trust it? By making it so that if you install something and it turns out to be a bad actor, that it can't do as much. Defense in depth. We've got multiple layers applying to this, and part of that layer is technology. So what I want to show first, we're going to kind of finally get into some code. So for the third of you who are developers, you're going to be like, yeah, awesome. We're actually going to look at some code finally. And for those of you who are not, we'll walk you through it. And talk through the extra layers of security that come. So we're going to go bit by bit. And so since we have a fair number of people who aren't developers, I'll explain what all of these things do. This is the event handler for clicking on the first button. And what this button is going to do is it's going to find the documents library folder from the known folders collection, and it's going to make a file. Real simple. That's all we're trying to do. Go to the documents folder and make a file, and put this file there, and put this text in the file, and then I'm done. That's it. Really simple. Make a file, put this text into it. So if I go ahead and run this application, I'll go and rebuild it. It'll deploy it locally, and when I click on this button, it's going to go try to make a file, but it's going to immediately run into an exception, handled by debugger, saying, oh, you're not allowed to go there. You got an access denied exception. Okay? And it's even going to tell me, conveniently, it requires a capability to be declared for that. So we'll go ahead and break and stop debugging and take a look at what our capabilities are. With every application, you define a series of capabilities that end up being represented in the token for that process, saying you're allowed to do this. You also see this in the store. This app will have the ability to do these things that are outside of the normal sandbox that we tie things into. So if I were to say, give this one access to the document library and then rebuild it, then when I try to create it, it would be allowed. The file sample.dat was created. And if I go and monitor what actually happened there, let me stop debugging and start up procmon. And take a look. Come on, there you are. Clear things off. And start monitoring. Let's run the application again. why it's out of date, but OK. Boop. It's created. Let's go back to Process Monitor, Stop Monitoring, and apply a filter, and look for everything where the path contains sample.dat. And here's what's interesting. So search is indexing it, so let's exclude that. That's not super interesting. And I got scanned by my antivirus engine, and Explorer wanted to display it somewhere. But what I noticed is that my program, which is called fileaccess.exe, never wrote a thing. This is how capabilities are handled. Your application doesn't actually have write access to your documents directory, and granting that capability doesn't give it write access to it. Instead, the runtime broker is what inspects to see if you have the capability. And if you have that capability declared, then the runtime broker will write it for you. So we don't jailbreak you from the limitations of your process. We find you a friend to do that work for you. A capability is a claim that you give to the runtime broker to do something on your behalf. It's very similar to what we do in IE. If you look at the process model for Internet Explorer in protected mode, we have a medium integrity process with a child low integrity. Low wants to save a document or a picture somewhere on your file system. It won't get it, and we don't jailbreak it to allow it. We just say, oh, well, the broker will let you if you follow these rules. Same thing here. It's a broker that says, I've got these rules. Do you have this claim? Oh, you do. Oh, it's certified claim? All right, I'll go ahead and do that for you because I know you can't. That's what capabilities do on your behalf. The runtime broker always does the work. So let's go to our next bit of code. What happens if I were not using this specific create file async API, but I were using a legacy Win32 API? Right? And for developers, when we think about those who are moving code over, right, it's real easy to tell a story about, hey, I don't have an app. I'll build an app, and I'll do it all Windows 8 style. Terrific. How many of you work in a company where you today just don't have apps yet? Yeah, turns out we are. Oh, really? You have no apps. Is it a brand new company? Is it a brand new company? So what do you do for, you just not have computers?
No Windows 8.
No, not no Windows 8 apps, no apps at all. Oh. Right? Everyone has this big body of existing code. No one's going to throw it all away and build new stuff. So we think about porting things over. So what happens if I were just using a legacy Win32 API to write something? You just stick it in my documents, this beautiful hard-coded path. The app compat guy would hate this. And just say, here's what I want to do to open it, all the old Win32 goodness. And if I don't have a thing, create an error, blah, blah, blah. This is the old way of writing an app. What happens if I click on that button? And it's going to get an error. And if I look at the process model, this one is called sample2.dat. Let's change the filter and add an additional criteria where the path contains sample2.dat. All right, and start it collecting again. If I try to write that, I can see, oh, I was creating this directly from fileaccess.exe, and it can't write there. Capability or not, right? Capability didn't let me write to documents. Capability let the runtime broker accept your request. Since I was using an API that wasn't leveraging the runtime broker, I still got swatted down trying to write to the exact same place. So if I then think through the security model, well, how could I write there? What's the first thing I'm going to bump up against? The first thing I'm going to bump up against is that this file access binary let me go and find this guy. Is it still running? Yep, there he is. File. There we go. It's purple. Yeah. It was a little bit too obvious for me, so therefore I clearly couldn't find it. Is running at this integrity called app container. What is app container? If I look at it, it turns out that the integrity level is low. Right, so there are some people, I've seen some reverse engineering done on the Windows 8 security model that claims there's a new one. There's not a new one, right? There's 4 billion possible ones. This is reusing low. And you can tell from the SID. This is the low SID, 4096. Same one. So I'm going to be blocked from writing to my documents because the default permissions I need are medium if I want to write there. So I historically would have been able to then go in and say, all right, well, I'm going to create this thing, and it's called, this is sample2.dat, right? Well, let me go ahead and make one, so there already exists one. So I'll go into my documents, and here's this sample.dat. Let me copy and paste it and rename this one sample2.dat. And then go back into the command line. I'm going to chml. And let's sample2.dat, and I'm going to mark it for low integrity, and therefore integrity won't block me anymore, and I'll be able to write there, correct? Let's go back to my app. Every now and then my mouse stops working, which is awesome, and try to write there still. And I continue to get access denied. This is what I was talking about before. If everything is at low, suddenly everyone's in the same cesspool. And if you don't want to be in the cesspool anymore, you've got to do something to break out and divide them. That something is that app container that we spoke of. So if I go back over into Process Explorer and take a look at file access in this app container, you can see that in addition to having the integrity label, it also has this app container SID. This is new. On Windows, identities had SID, users, and groups. What we added for Windows Vista was that a service could also have a SID. Right? That's how we implement Windows Resource Protection, is that we use a service SID, and we have the Windows Modules Installer service, the only one that's able to modify Windows binaries. That's the thing called Trusted Installer. That's not an identity that you could log in as. That's a service. And it's using a service SID. With Windows 8 store applications, you have an app container SID that uniquely identifies your app. This app container SID is based upon a hash of the package name. All right, it's an SHA-256 hash of the package name to generate this SID. That will be unique to anything with this name. And with that SID, we can then enforce security that also says that this app container, in order to get there, has to have permission. So if I wanted this app container to be able to read or write from something, then I need to, where'd my app container guy go? Let's get him at the top. I'll need to grant this app container permission to write to it. So let's go back into the command line and modify the permissions one more time. We'll just use iCackles, and we'll do sample2.dat, and I'm going to grant, and there's no way I'm going to type this number correctly, so I'm just going to paste it. Oops. Paste. And grant it full control. So I've added this app container, right? The identity in the security infrastructure for this particular binary. And with that grant, now I can write there. Yes? So it's based on the hash of that name, so it's as long as it has that name, it will continue to have that SID. All right, in exactly the same way we do that for service SIDs, the service SID is based upon an SHA-256 hash of the name of the service as well, right? So clearly, if you're doing side-loaded apps, there's the potential for some squatting, right? If you just give it the exact same name as something else, we obviously in the store verify that you're not taking somebody else's name. And in the enterprise, you want to do the same thing. When you do side loading, it gets digitally signed by the enterprise. So the enterprise would want to make sure that you're not doing something nefarious like that. There is responsibility in a vetting process to be built up to ensure that you don't do that, since it is, you know, a known, right? And Alex Ionescu actually writes to some detail about this generation process. But it is based upon just a hash of the name that will always be the same. The other possibility is if you go into the security descriptor for this, go into security, and go into edit. I could also add, oh, come on, why are you locking up on me? You are so not being my friend right now. That's awesome. If only we had a debugger attached to this thing, we could turn it into an impromptu debugging demo. Now what we'll do is we'll go through and yeah, it's resolving everything. This is the beauty of being connected via direct access via a not exceptionally fast network is that we are actually waiting for things to go over the network from time to time, which is really quite irritating. So we're now waiting to see all of the possible domains that Microsoft has that I could choose from, which is really annoying. And once we get down there, we'll see that there is, in addition to an individual SID for every single possible app container name, based on the actual name of the binary, but there's also a single identity for all app containers. So if you wanted to say an app, a Windows Store app can always get to me, you would have the option to do that. Yeah? It's not just the name of the exe, it's the actual name that gets embedded. As detailed right here, the package name is what it gets embedded from. So the actual compiled binary, right, you wouldn't make a set.exe because you have a wholly different packaging format for Windows Store apps. But you would want it, we do recommend you should have your publisher name. So in this case, we did Microsoft.SDK samples, which is the product name, the specific instance, and this one happens to be the C++ because there's multiple ones, so they're all unique. So to give it a, hey, this is from this company, this team, this product, subproduct, however detailed you need to get to make it unique within the constraints of 256 characters, I believe. Yeah, and I'm going to go, assuming I can actually get Explorer to work and not be hanging anymore and resolve stuff. Let's get everything out of the way. Yeah, it's still hanging. There is one that is all app containers. And you can apply that one also if you had a resource where you're like, you know what, any app container can get here. That one is OK also. Oh, finally, resolved. I just want the local, which is super fast. I had to wait for that. I can go into advanced, and I can say find everything. And I can see that I have this all application packages, right? And I can add that as well. So that's an option. Yeah, question? I'm not aware of current plans in that regard. That doesn't mean they're not under consideration. So the only thing I know that's coming for 8.1 is the concept of the child app container, which is the ability to start having relationships between store apps, which is not really possible with pure isolation, whereas if you have children, and there are a few very specific scenarios that we're targeting in the formerly known as Blue. Don't ask me why we actually always start off with cool names and end up with boring ones. I don't know why that happens. Clearly, I don't understand marketing people. But yeah, the idea of going in that direction. Now, what other ideas may be coming in place? You know, the initial challenge we were trying to solve is the way that Windows apps are done in the past. You literally can't trust them because so much of them is malware. So if we can start to build a trusted experience, then all of a sudden people will start installing more apps. And that's the initial problem to try to solve. Now then solving them within different domains, sideloading is starting to get more attention. I know that there's focus coming on understanding the scenarios that are not met and building solutions. Now whether the solutions will mirror other existing solutions or whether they'll be completely different, that's still, a lot of that is still under planning right now. Yeah, and then there's some additional controls that you also get based upon app containers. So when you look at, like we look at the firewall, I think it actually beeps at me to tell me there's 5 minutes. You know, you can start to control where things can go through the firewall. Ours are all locked down by policy, but you actually have individual app container level control in the Windows firewall, right, to start to restrict that. So you know, we are looking at this as an independent, securable entity, and that's important. Other aspects of isolation, and I've got a couple minutes left here, that I think are worth noting. Where's my app? There it is. Actually, no, this is actually a super important concept. I don't want to fast forward through this one. At the very beginning, I went through and I created this capability so it could write to the documents library. That is a bad idea, and it will almost certainly get your app rejected from the store. You don't need the documents library capability to write to your documents library. You only need it if you want to write there silently. If you want to write there visibly, I can take away this documents library capability and go through an API that, instead of writing it silently, goes through a dialog box that the user picks, then that will be allowed. Again, it's going through the broker, but the broker is saying, hey, does the user know this is happening? In which case, it's OK. Oh, it's hidden from the user? It needs the capability to enforce that. And the capability is designed for some very specific scenarios, which are not write a document at all, right, but other scenarios as well, all blocked by that same security. The final layers that come in place are around things like the object namespaces that you have. So if you look at a kernel mode object, this is creating an event. And this event, I don't want procmon, I want procexp. File access, I look at the details here. Let me actually show the lower pane. And here's an event. And what we did with this event is, when we were creating it, I'll look at the code. We said, create a button, create event, call it my event. What do we do along the way? Here's my event. We happen to inject app container named objects / the app container SID, so it is isolated from other events of the same name. So if we used to be, you could do namespace squatting. If I happen to get there first and know what you're going to call an event, I make it first, you can't make yours, or you can and you'll join on to mine and I can spy on you because I've set up the security on it. Right? I could do some name squatting and use that as an attack vector. We isolate them. In addition, we go in, and if I look at app data, right? So if I go to local app data and I look at packages, I've got all these different packages. They have their own private app data, isolated from other people's app data. If I go into the registry, right, let me pop open regedit. Of course, it's going to take a nice long time to start because I am not being blessed by the demo gods today. And I see that under HKey classes root, local settings, software, Microsoft Windows, current version, app container / storage, I have an individual entry for all of my store apps for their own private registry storage as well. So across the board, here's an identity. We keep isolating their events, their app data, as well as their storage, so that they have a place they can write, but it's not a shared location with everybody else. So we've gone beyond the notion of admins, the box is yours, standard users on desktop apps, your profile is yours, Windows Store apps, your app is yours. Gradually bringing it down so that if you get an untrusted agent, there's less damage you can do. All of this enforced by vetting at the store level or vetting at the enterprise signing level, which you're on the hook to do to build a far more trusted app story on Windows 8. So with that, thank you very much. I hope this was useful to kind of get under the covers on some of this stuff, explain. Lots of stuff's been around, but people still aren't getting it. So hopefully you can help me spread the word, and thank you once again for coming.